I'm messing up. She's doing it right. So today we're looking at the constant rate of change. It's really similar to what we were looking at last week. Last week we were studying the rate of change. We're studying the unit rate. This what we're doing today and tomorrow is super similar. We're going to start by looking at some vocabulary. The vocabulary is not going to be like crazy intense, but we're going to be using some words that sound funny, but we already know how to use them. So rate of change. All right, so rate of change is how one thing changes in relation to another. So a rate of change is how one thing changes in relation to another. So miles per hour. If I'm going 1 mile, or I'm going 1 hour, how far do I go? If I go 2 hours, how far do I go? So the number of miles that I go is dependent on the hours that I travel. The ratio of students to teachers. If I have 2 students per teacher, and then I have 4 students, I'll need 2 teachers. 6 students, I'll need 3 teachers. Things change in relation to each other. A proportion A proportion is where 2 rates or ratios are equal. Pretty much exactly what we said earlier today. 2 rates or ratios are equal. A ratio is just a fraction comparing 2 things. 2 fractions that are equal to each other are proportional. A rate is just a special type of ratio. Constant of proportionality. So the constant of proportionality represents the rate of change. And this actually has a funny little symbol that we use. We use a K to represent the constant of proportionality. And it represents the rate of change. Think unit rate. All right, let's look at a couple examples. So in 1 hour, of babysitting, Emma makes $8. And Emma makes $16 in 2 hours. And $24 in 3 hours. All right. So Emma's babysitting. In 1 hour, she makes $8, $16 in 2 hours, and $24 in 3 hours. So what I'm going to do is set up a chart to help us look at their numbers. So time is in hours. And then the total amount of money that she's making. So in 1 hour, she's making $8. In 2 hours, she's making 16. And in 3, she's making 24. So we need to determine if it's proportional. So to determine if it's proportion, 2 rates or ratios are equal. So what I want to find is the unit rate. I need to figure out if the unit rate is the same for all of them. So dollars per hour, I'm going to do $8 per hour. So that means numerator divided by denominator gives us 8. Dollars per hour for our second is 16 to 2, which reduces to 8. My third one is going to be 24 to 3, which also reduces to 8. They all have the same rate, so is it proportional? Yes. All of these fractions are equivalent, so it is proportional. The second thing we have to do is write an equation. And we write it like this. Y equals kx. Our first little algebra that we're learning. Y represents our output. It's what we're producing, what we're trying to get out of the equation. In this particular case, it's money. K represents our rate. And X is our input. So our constant of proportionality, what's the rate that she's earning money? $8 per hour. So our constant there is 8. So our equation is Y equals 8x. That's our equation. Y represents the amount of money that she's earning. X is the number of hours that she's working. Now the reason that that equation is nice is because if I said that Erin was working for 10 hours, we could do 10 times 8 and get 80. So she'll be making $80. That would be really nice for her to know If she's working 10 hours one day, 3 hours another day, she can add up those hours, multiply it by 8 to find out how much she's going to be making total. Let's look at another one. This time we'll just use a chart. So Brad's going to wash cars. In 1 hour, Brad washes 3 cars. 2 hours, Brad washes 6. In 3 hours, Brad washes 9 cars. And in 4 hours, Brad washes 12 cars. So our first question is it a proportion? Is this a proportional table? And we can look at the cars washed per hour. So that's 3 to 1, reduces to 3. 6 to 2, reduces to 3. 9 cars to 3 hours, reduces to 3. And then 12 cars in 4 hours, reduces to 3. So is it proportional? Yes. All of these fractions are equal to each other. They're at the same rate. So it is proportional. What is our constant of proportion? What is our constant of proportion? Morgan? Perfect. And what's my equation going to be? So I know it's proportional. I know my constant's 3. Ryan, what's my equation going to be?
K equals 3x.
I think y equals 3x, I think is what you meant. Yeah, y equals 3x. What does my y represent? What is my y going to represent here? Dave?
Output.
Yeah, my output. Which one's my output? The time or the cars washed? Yeah, the cars. And what does my x represent? Right, my hours. Let's look at one final example. Allie, is it A-L-L-Y? What?
A-L-I-E or A-L-Y?
It's usually Y.
Yeah, but I'm asking Allie.
Oh.
Why? All right. No. I'm asking specifically. So Allie takes 1 hour to read 35 pages. 2 hours to read 70 pages. 3 hours to read 105 pages. So answer some questions. Is it proportional? What is your constant of proportionality? And then what is your equation? I'll give you a minute to do that. All right, you've had a minute to look at that. Sophia, is this proportional?
Yes.
Yes. And why did you say yes?
Because 35 is 35, 75 over 2 is 35, and 105 over 3 is.
So when you reduced all of them, you found that they all reduced down to 35? Excellent. Yeah, absolutely. What is my constant of proportionality? Olivia, what is my constant of proportionality? No, it's not 70. Notice here, I found that it was 8. That was my rate. Here I found my rate was 3, because everything reduced to 3. So what do you think it is here? It's what everything reduces down to. Whoa. What do all of those reduce down to? Not 3. Now help her out. 35, right. So the constant of proportionality is the rate that everything's changing, and it's changing by 35. Every hour that she reads, she goes up by 35 pages. So what's my equation here? Abby?
Y equals 35x.
Perfect. 35x. And what does the x represent in this equation, Ty?
Yeah.
The input, which is pages or hours? So if I take pages and multiply it by 35, it tells me how many hours? Or is it I take my hours, multiply it by 35 to find out how many pages? Yeah, that's my hours right there. So 1 hour times 35 gives me 35 pages. So our output is the number of pages we read. Our input is the number of hours that we read.